Hey guys, so last Tuesday you did lesson 9.2 with me. This is 9.3, surface area of pyramids and cones. I'll just give you a chance to write down the words here. We've learnt in lesson 9.1 to classify certain polyhedra into two classifications, prisms or pyramids, based on the number of bases, so if you can write this in your notes, and their shapes of their lateral. Prisms have two bases that are parallel to each other, and the lateral faces of prisms are rectangles. Pyramids, on the other hand, have one base and the lateral faces are triangles. Don't forget, you can stop this at any time to catch up. So I'm just going to move across. In lesson 9.2 we developed a formula for finding the total surface area of prisms and their close first cousin, the cylinder. It involved two types of areas, the area of bases, which we call capital B, and lateral areas, which are always rectangles. The formula for SA, the surface area, remember SA, surface area of a prism, is surface area is two bases plus pH, and we did all this last Tuesday. The formula for the cylinder, 2 pi r squared, remember pi r squared, area of a circle, so that's the two ends of a cylinder, plus pi dh, and all of this we did on Tuesday. So I'm going to jump down now to this one. This is the square-based pyramid. Okay, notice we've got the base, which is in the shape of a square. There it is. Will this always be the case? No. It could be a triangle, it could be a rectangle or other shapes. How many bases will every pyramid or cone have? Well, you can always put it onto a base, so the answer is always 1. So we've discovered the first major difference in the formulas of pyramids, that there's only ever one base. Remember, a rectangular prism, you could put it onto 6 different faces. The second variation of the formula we need to be aware of is the height measurement. Did you notice the two different heights? We've got the height here from the vertex right down to the center of the square base, whereas here we've got the height which is the slant height. This runs down the center of one of the faces. So the height measure we need for the lateral area in this formula is the height of each of the triangular sides. That's the one here, the slant height. And how is that different from the height of the side of a prism we'll come on to in a few minutes. So let's move to the next page. This is basically what you need to know. Knowing that we only need one base area, here it is, just in green here, the base area. We need the area of the base plus half of the perimeter of the base. That's the distance all the way around. Remember, if it's a square base, it would just be the perimeter of a square, multiplied by the slant height, this height here, which is perpendicular. Remember, it makes a right angle with the side of the base. And in symbols, the surface area of any pyramid is the base plus perimeter times slant height divided by 2. Before we can find the total surface area, we may have to do a bit of work to find all the measures we need. Now, we know lots of things like pith and other things that we can use. So what we're going to do then, we need to find the slant height. What shape is the base? You can all write in your notes, this is a square. How do we know it's a square? Simply because these two sides here are congruent, so that gives us a square. What other measurement is given? Well, we've got this height from the vertex to the center of the base. That is not the one we need. We need L, which is our lateral height. So we need to use something, your old friend Pythagoras. So I've drawn the triangle here. This is the height here, 8. it makes a right angle, and then what I've actually got is really this coming across here, which is half the length of 10. So we get 5. So then we do our old friend Pythagoras, as I said. So L squared is equal to 5 squared plus 8 squared. When you work everything out, we get 25 plus 64. So L is equal to the square root of 25 plus 64, which is 89, which gives us a height of 9.4 meters. So this slant height is 9.4, and it's sensible, isn't it, that it's longer than the 8 here, because as we know, that gives us our longest side. So there's your example 1 done. Find the slant height, and we do actually need that. Let's move on then. Now it says find the slant height of the pyramid and cones below. The process is exactly the same. So I'm going to go to this one here. I'm going to draw my right triangle just like I did on the other one. Remember, it's half of the side. So this one is 9 feet. There's our right angle. We're given the true height, the 15 feet. We have to find L. We can do that by doing 9 squared plus 15 squared, and then we take the square root, and that all comes out as 17.5 feet. Again, check, it's longer than this side here. Now we go to a cone. Remember, a cone has got a circular base, but it doesn't matter. We still get the right triangle. There it is. This time, this side is actually a radius, and we've been given it there. It's 3 inches. The height here, remember, it's from the vertex to the center of the circular base, is 9 inches. And again, we can find our lateral height. L is equal to the square root of 9 squared plus 3 squared. So that's going to be the square root of 81 plus 9, which is 90. And when we do the square root of 90, we actually get 9.5 inches. Remember, all we're doing here is finding the slant height using Pythagoras. Okay guys, so we're on to example 2, finding the surface area of this good-looking square-based pyramid. Here it is. Remember, this will be made up, if you flattened it out, it would be a square-based, and basically 4 triangles, and adding all those areas together. So what shape is the base? You can write in square. Again, we know because it's a 10 by 10, and that's what we need now, the area of the base, capital B. 10 times 10, 100 meters squared. We also need the perimeter of the base. Very, very simple. 10, 10, 10, 10, isn't it? Going all the way around the base. So that's 40. So we have 2 parts. We just need 1 part left. I'll give you the formula again in a minute, but we need the slant height. And again, that's our good friend Pythagoras. I've already drawn the triangle here. We've got the height 8. It's half of the base 5. When you do Pythagoras, remember, it is the square root of 5 squared plus 8 squared, and that will give you 9.4 when you do that on your calculators. Find the lateral area. Important warning. What shape is each lateral face? It's obviously a triangle, isn't it? What do you recall about finding the area? We did this back in chapter 8 with me. It was the area of a triangle is base times height divided by 2. Therefore, the lateral area is the perimeter of the base multiplied by the slant height divided by 2. And that's how we arrive at plugging in everything here. Now I've cheated a little bit. I've already put the answer 288 meters squared. The base, remember, we got from up here was 100. We add to that the perimeter, which was 40, multiplied by our slant height, which is 9.4. And remember, we have to divide that little bit, not everything, just this by 2. This stands alone. And hopefully when you use PEMDAS, so you're going to do this bit first, finally add in 100, you will get 288 meters squared. Okay, so what I've done here is I've made it a little bit easier to understand, to be honest, because the base, again, is a square. It's 2 by 2, which gives us 4 meters squared. The perimeter, remember, of the base is 2, add 2, add 2, add 2, which gives me 8 meters. Okay, so this time we don't actually need Pythagoras, because if you notice, we've already got our lateral height. So this time we actually have got 3 meters to put in, and now look, I have B, P and L, which is what I need here for the surface area. So the surface area of this pyramid is 4 for my area of the base, plus the perimeter, 8 multiplied by 3 divided by 2. So 8 times 3 is 24, divided by 2 is 12. 4 add 12 is 16 meters squared. That is my total surface area of the base and the 4 lateral faces. This one, the base, 18 times 18, which is 324. The perimeter, 4 times 18, gives me 72. This time I do need Pythagoras. Okay, I'll draw it down here. This one, 15. We've got half of this side, which is 9. When we do L, we need to do L is equal to the square root of 15 squared plus 9 squared, which gives me the square root of 225 plus 81, which is 324, which gives me 17.5. I can now write this one in up here. So when you plug these numbers in, remember to add the base at the end and do PEMDAS, we end up with 954. Remember, it's feet squared because we're talking surface area. Please check with these numbers that you end up with 954. Let's move on. So there is our cone. We're now going to do the surface area of a cone. Fairly similar. Let's go straight to the formula here. Where did pi r squared come from? Do you remember back in lesson 8.7 we did the area of a circle, pi r squared. Reason? Because it is the area of the base. Then we're going to do pi times d times L divided by 2. Again, pi times d. That is our perimeter. Remember, special name for a circle, perimeter is circumference, and that is what pi d is. There it is, circumference of the base, and again, multiplied by the slant height. If you're lucky, they'll give you the slant height. If not, use Pythagoras. Okay guys, in example 3, we're finding the surface area of the pyramid. The pyramid happens to be the cone. Remember, a cone has a circular base. So, what shape is the base? There it is, a circle. Now the base, if you remember back in 8.7, we did pi r squared. So we take our radius 6, we square 36, and we'll leave in terms of pi. So it's 36 pi. Perimeter, remember, is the circumference, and again back in lesson 8.7 we learned that circumference is pi times d. The diameter here, we double the radius, so it's 12. So we've now got 12 pi. So we have 2 parts, B and P. We now need to get slant height. We will have to use Pythagoras here because we need this height here, which is the hypotenuse of this triangle. I've just drawn it down here. 6 and 9. 9 squared plus 6 squared, square root, it gives me 10.8. So I now have B, P and L. Again, the important warning, I won't go through it all again, but it's about the triangle, and the triangle is base times height divided by 2. So this pi dl has to be divided by 2, but again, the area of the base stands alone. So we put our pi r squared in. That came from 36 pi. Here it is. Then we add to that pi dl. So pi d is our 12 pi, and L is 10.8. I'm just going to squeeze the 10.8 in there. Don't forget, we've got to divide that by 2. Now this is where you do need your calculators, 36 times the pi button. But don't forget, let's leave that till last. Let's do this first. 12 times pi times 10.8. Press the equals button. Then divide by 2. Press equals again. Add. You might want to open up parentheses here. 36 times pi. The important thing is, guys, get 1008 times pi. and that is the surface area of your cone. If we move down, we're now going to do similar to what we did with the pyramids. Let's see how far we get with this. This is what we're aiming at. Remember, this is the area of the base. We have the radius, 3 inches. The diameter then is double that, so it's 6 inches. This L, remember, to get L, we need to use Pythagoras again. Same old thing, 9 squared plus 3 squared, and we get our L, which I can tell you is 9.5. So now we have all the ingredients to go into the surface area. Pi r squared, pi times 3 squared is 9, plus pi times d, that's pi times 6, multiplied by 9.5. All of this has to be divided by 2. When we get this in terms of pi, we get 9 pi for this bit here, and we get 28.5 pi here. So we can actually leave everything in terms of pi, and it's 37.5 pi meters squared. Check you get that. Let's have a look at the other one here and see how far we can get with that. The diameter here, isn't it? Diameter is 20. So therefore we have to work backwards to the radius, which will be half of that, which is 10. And so I'm going to draw my right triangle here to find L. Remember, here's L. Okay, so my right triangle with L being here is going to consist of the 7, and half of 20 is 10. So it's the square root of 10 squared plus 7 squared, which is 149. So really L is the square root of 149. Well, we know that's going to be over 12 and less than 13. And hopefully on your calculators you find it's 12.2. Now I can put everything into my surface area. Here it is. Pi r squared, 10 squared is 100, times pi is 100 pi, plus pi times 20 times 12.2. I'm going to use multiply signs here, all divided by 2, and this comes out as 222 pi inches squared. Okay guys, as you know, this is the do it together section. Now I'm hoping that you actually can do A, B, C, D, E and F here with 1 through 6. Have a go at doing that. Now when we come down to 7, 8 and 9, I'm not going to waste time on going through this, because everything with the slant height here, that's Pythagoras. Remember, your L is here on the hypotenuse. Here, look, you've got your 10. This is a right angle, 24. So your L is there, again, Pythagoras. And the same thing here, just because it's a cone, there's your right triangle there. So again, this is what you're looking for, L here, so 16 squared plus 30 squared, square rooted, etc. Okay, so with the surface area of a pyramid, remember the 3 ingredients are base, perimeter, slant height. And you throw them into this equation. The surface area of any pyramid is the base plus, remember the base stands alone, perimeter multiplied by the slant height divided by 2. And immediately we can take that into this question here. Straight away my slant height, I'm lucky here, I don't need to use Pythagoras because I'm given it. My base is 7 times 7, which is 49 centimeters squared. Perimeter, remember, is just 4 sevens added up. It's the square base. 7 add 7 add 7 add 7, 28 centimeters. And then to save time again, you're going to put these into this equation here. And you should get the answer 161 centimeters squared. So I'll leave you to throw those in here, and that's the answer you should get. Likewise, I'm just going to give you the answers to 12 and 13. For number 12, you should get 864 meters squared. and for this one here you should get 65 yards squared. Hopefully you can do those, again, all based on the surface area formula. We'll just move on and do one of the next few. Again, listing the 3 ingredients. This time we want our R, D and L, but it's still based on the same formula, which is the area of the base. Remember, we're talking cones, so it's a circle. We know pi r squared, and then we're going to add to that pi d l, that's the circumference, remember, multiplied by the slant height, and we divide it by 2. If we're doing number 16 then, radius, 3 feet. Diameter, remember, is just this doubled, no tricks at all. 6 feet there. And the lateral height, we're already given this, it's 4 feet. So again, we've got a little bit lucky. Now we're going to throw them into this. And again, saving a little bit of time, let's hope that you can get 21 pi feet squared as your total surface area. I'm going to give you the answer to number 17. I'm just going to write in for you that the radius is 5 meters, so we've got 10 meters for the diameter and 11. And again, if you throw those into the formula, you should come out with 80 pi. That's leaving it in terms of pi. If you want to do it as a decimal, that's fine. Just do 80 times the pi button. And again, with this one over here, without filling these in, you must fill these in, please, before you attempt the homework. 96 pi inches squared. Still on do it together. A cone, let's do number 20. A cone has a diameter of 12. So here's my cone with 12 inches as the diameter. Straight away I'm going to write down the radius is 6 inches because it's just half. Okay, and a slant height of 8 inches. Now you've got all the necessary ingredients you need. Quick sketch of the cone, here it is. Okay, so we've got a radius here of 6 inches. There's the true height coming down, but we've got the slant height, which is 8 inches. So again, we throw it into our formula, which is the surface area is the area of the base, pi r squared, plus pi d, which again is the circumference, multiplied by the slant height divided by 2. Remember, this doesn't get divided by 2, it's just this. And again, I'm expecting you to throw those in there and get 84 pi inches squared. That pretty much does it for the do it together. You're now really ready to have a go at the homework. All the best with that. Remember, you can contact me on Remind. That is okay if you get stuck. It is a little bit complicated. Hopefully you'll stop and start this video and really get to grips with what we're talking about. It's the surface area of pyramids and cones. All the best.